Hello, calculus fans. Let's talk about limits of vector functions. The way we'll compute limits is just by taking the limits of component functions. So we'll make a definition to say that if r of t has component functions f, g, and h, then the limit as t approaches a of r of t will be the vector whose components are the limits of the respective component functions. And this is provided these limits exist. So as an example, let's find the limit as t approaches 0 from the positive side of r of t. And here r of t is going to be the vector function with components 3 plus t to the fourth, te to the negative t, and t squared log of t. So we just find the limit of each component. The x component, easy, we just get 3. And the second component, also easy. So in each one of these cases, we can use the direct substitution property. We'll just plug in the value of t. All right, the third one, not so easy. It's going to need L'Hopital's rule. And that's because the limit of this piece here is 0, and the limit of this piece here is negative infinity. That means it's an indeterminate form. We don't know what the limit is. It's not just 0, necessarily. Saying it's 0 times negative infinity doesn't really tell the whole picture. The t squared is not 0, it's going to 0. All right, so this is an indeterminate form. We'll apply L'Hopital's rule. So the limit as t approaches 0 from the positive side of t squared log t is equal to the limit of log t over t to the minus 2. So when you have an indeterminate form that's 0 times infinity, you have to make it into a fraction. Then we apply L'Hopital's rule by separately differentiating the top and the bottom. A little bit of algebra allows us to rearrange this. And now it's okay to use the direct substitution property and just plug in t equals 0. So here's our final result. We can say that the limit as t approaches 0 from the positive side of r of t is equal to the vector 3, 0, 0. Okay, that's all for now.